Day 512 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 812, largest triangle area. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an array of points on the xy plane points where points of I is equal to xi, yi, return the area of the largest triangle that can be formed by any three different points. Answers within the 10 to the negative power of the actual answer will be accepted. All right, y'all, so that sounds pretty simple, but let's take a look at these examples just to make sure that we are doing this problem correctly. Now, the first thing I just want to point out real quickly is when it says 10 to the negative fifth power, or answers within 10 to the negative fifth power will be accepted. That just means the answers can go up to the fifth decimal point. So as you can see in the output, they give us five decimals after, or they give us up to 5 points after the decimal, right? The fifth decimal point. So that's what this 10 to the negative fifth power means. Now let's get into the example. So in the example, we have our input points equals a 2D array of integer of points. First point 0, 0, then 0, 1, then 1, 0, then 0, 2, then 2, 0. Our output is 2.0. The explanation says the 5 points are shown in the above figure. The red triangle is the largest. So let's break this down one step further. As you can see, they give us our points right here, and they mark all of the points on this graph, right? So these 5 dots right here just represents each one of these points. So now that we know where the 5 dots go, we want to see what's the largest triangle that we can create, or create the triangle with the largest area. So as you can see, we could have created a triangle by connecting these 2 points right here. However, it wouldn't be the largest possible triangle that we can create, because we can also connect these 2 points right here. And when we connect these 2 points right here, this is the largest possible triangle that we can create. But we're not done yet, because we still need to find the area. Hence the title, largest triangle area. We need to find the area of this triangle. Now, to find the area is not that hard. It's just 1/2 times the base times the height. Sorry, y'all. Times the height equals area of triangle. Boom. So as you can see, this is our base right here, and then this is our height right here. So the base is 2, but we're going to do 1/2 times the base. So that means half of 2 is 1, and then the height is 2. So 1 times 2, or 1 times 2, gives us 2, and that's how we got our output of 2, because that's the area of this triangle, or the largest triangle that we can create. So let's take a look at example 2. Example 2, they don't give us the graph, but let's go through it anyway. We have the points equals a 2D array of integers with the points. First point 1, 0, second point 0, 0, last point 0, 1. This time the output is 0.5. So I hope that makes sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult. So first thing we're going to do is we're going to create a constant that's going to let us track the total number of points. So we can say let n equal points dot count. Boom. Then we need to track the maximum triangle area that we have found so far. So we can declare a variable, call it max area, and we could just set that equal to 0.0. Boom. Then we're going to iterate over all unique combinations of the 3 different points. So we're going to say for I in 0, sorry y'all, for I in 0, dot less than sign, n, open of the brackets. Then we're going to say for j in, sorry y'all, I don't know what's up with my keyboard, for j in I plus 1, dot less than N. Then we're going to open up the brackets. And then we're going to say for K N I, or excuse me, not I, J plus 1 dot less than N. We're going to open up the brackets again. Then we need to extract the coordinates of the 3 chosen points. So we're going to say let x1, we're going to set that equal to points square bracket I, come outside of that square bracket 0. Then we could copy and paste this. We could bring it under. And this time we're going to say let y1. So we're going to change this x to a y. And we're going to say points I of I square bracket 1. Then we're going to do that again. So we copy and paste this again. This time we're going to say let x2. So it's x2, then points, and it's points j and square bracket 0. Then do the same thing. We could say this is x3, or excuse me, this time this is y2, and this is going to be points of j square bracket 1. Boom. Then we come do that again. This time we're going to say this is going to be x3. We're going to say points k square bracket 0. Come back again, and I'm sure you guessed it. This is going to be x, or excuse me, this is going to be y3. Then this is going to be k and square bracket 1. Boom. Now we need to compute the area of the triangle formed by these points using the Scolase formula. So we're going to come underneath this. We're going to say let area equal ABS. So the absolute value, open up the parentheses, is going to be a double. We're going to open up the parentheses again. We're going to say x1 times, open up the parentheses, we're going to say y2 minus y3. Come outside of those parentheses, we're going to say plus x2 times, open up the parentheses, this time we're going to say y3 minus y1. Then we'll come outside of this parentheses, we're going to say plus x3 times, open up the parentheses, and we're going to say y1 minus y2. Then we're going to come outside all of these parentheses, and we're going to divide it by 2.0. Boom. Then we need to update the maximum area if this triangle is larger. So we could come right here, and we're going to say max area equals max, open up the parentheses, max area, comma, area. Then we're going to return the largest area found among all possible triangles by coming down here, and we're going to say return max area. Now that should be all she wrote, y'all. Let's go ahead and give it a run, make sure it runs correctly. Okay, so now it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This the top. This the rest of it. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.